So we are going to be talking about some properties of exponents, and now we're going to be focused on fractional exponents. And so as we look at this front screen here, we're really going to be focused on rewriting rational exponents and using kind of our properties of exponents with fractional exponents. So what does a radical expression mean? Here's what radical, both a radical and a rational expression. If I have a fractional exponent here, a to the n over m power, then I'm going to be taking the mth root of a to the n power. I know that sounds really goofy and confusing, and so let's break this down a little bit. Okay, and I think I skipped a slide there. So what does that mean? Well, let's think about what we know. We know that the square root of 36 means what number times itself is going to equal 36. And so 36 equals, that number is 6 times 6. And so we can say that 6 squared, and then the square root of that equals 6. And so we're getting there. And then, of course, a cubed root means what number times itself 3 times is going to equal 64. So the cubed root of 64 is, 4 times 4 times 4. Yeah, that's 64. So 4 to the third power, that's 64. The cubed root of 3 is 4. And so here's what a fractional exponent means to us, or this cubed root, if you will, can be written as a fractional exponent. And what we're talking about here is the cubed root of 4 to the third. If I play this backwards to our definition, then I know that this is the same thing as 4 to the 3 over 3 power, which that simplifies to 1, which is 4. And so that's how all of this works. I want to go back to that slide one more time. Okay, so I want to look at what we just looked at, and I had the cubed root of 4 to the third. Okay, so my m is a 3, my n is a 3, and when I make my fraction, I end up with 4 to the 3 over 3 power. And when I simplify that, I end up with just 4. So that's how this thing kind of works. So if we look at them side by side, which is what we just did, okay, we know what our m and our n values are and how that's going to simplify down as our fraction. Okay, I don't expect you to be masters at this right away. So the first thing I want you to do is write down this square root chart. You can hit pause, write it down, but I want you to notice that the square root is the same thing as the 1/2 power. Okay, and that's really hugely important that a square root and the 1/2 power are the same. So hit pause, write this down. Now we have a cubed root chart. So a cubed root is the same thing as something to the 1/3 power. So if I'm looking at my chart here and I had 125 to the 1/3 power, it would be the same as the cubed root of 125. Go ahead and hit pause, copy this chart down. And then we'll talk about the quartic root. So again, the 4th root of something is the same thing as x to the 1/4 power. Go ahead, hit pause, copy that down. And then the quintic root chart. So anything that's the 5th root is the same as x to the 1/5. And these are all numbers that I need to take times themselves 5 times to get that root. So 2 ways that we can look at this. We've got x to the m over n power, which we've been talking about, and that means the nth root of x to the m power, or it can mean the nth root of x, and once I've done that, then I take it to the m power. And I'll show you how or why that can make a difference right here. If I look at 125 to the 2/3 power, okay? If I do the cubed root of 125, and that comes right from our chart, I get 5, and then I'm left with that number squared, and that comes from my m value. and then I get 125. So I'm able to simplify numbers with fractional exponents because of my chart and because of depending on whether I square it like this one or if I square it on the inside. And so let's take a look at how this could work in an or kind of a way. If I have 4 to the 3 over 2 power, I can go ahead and cube that first. So there's my 3. I've got 4 to the 3rd, and then I would look at the square root. So if I did 4 to the 3rd, I get 64. Then I do my square root, and I get 8. Or I could look at it this way. I could do my square root first of 4 and cube later. So my square root of 4 gave me 2, and I cube that, and I get 8. Either way, I get 8. Okay? And sometimes we get problems that it doesn't matter whether we cube first in this case and then square root, or whether we square root and then cube. But some problems, like the one that we just looked at, are only going to work in that one specific way. So we're going to look at a bunch of examples here and see if we can't go about practicing some of these. And we're going to work on them together. So I'm going to rewrite this first of all as a cubed root with an exponent. And so remember that this is going to be my 8, and I've got the cubed root of that. And so now I want to decide whether I want to put my exponent here, my power of 4 right here, or whether I want to put parentheses and put it out here. And here's one easy way that I kind of gauge this. When I make my root, so I knew that I was looking at the cubed root because of my denominator, what I do is I go back to my chart and I look at my chart. And if I know that cubed root, then I want to put parentheses and I want to do that exponent later. So because I know from my chart the cubed root of 8 is 2, I now have 2 to the 4th, and 2 times 2 is 4, times another 2 is 8, times another 2 is 16. And so that's going to simplify to 16. And again, what I do is I look at my denominator, that tells me my root, and then I look at my chart. And if that number is in my chart, then I'm going to do that first and then my exponent. So this time we're going to amp it up here. We've got 27x to the 6th and this to the 1/3 power. Now this is where our exponent rules are going to come into play, and I'm going to follow them just like I have with whole numbers. So first of all, I've got the power rule here. Everything is going to get this exponent of 1/3. And the power rule tells me to multiply those exponents. And so here's why we practiced with fractions. So I have 27 to the 1/3, and I have x to the 6/3. And so I'm going to simplify if I can. 27 to the 1/3 should come right from our chart. It's the cubed root of 27, and that's 3. X to the 6/3 power, I'm going to go ahead and simplify that fraction, and I get 3x squared. So our exponent rules are going to follow just like they always have. Okay? Again, this is going to be an exponent rule here. This is the product rule. And I've got the same base. Both of my bases are x, and so I'm going to add these exponents. I would have x to the 2/7 plus 3/14. To add fractions, I have to have a common denominator, so that would give me 4/14 plus 3/14. And that's going to give me x to the 7/14, and I want to simplify this down as far as I can, and so that would simplify to x to the 1/2 power. Oh, this one looks like a doozy. Okay, I've got 16x to the 14th over 81 y to the 18th, all of that to the 1/2 power. So remember that I am going to observe my exponent rules the same as we always have, and so every piece on the inside of this parenthesis is now going to receive this 1/2 power. So I have 16 to the 1/2 power, x to the 14 times 1/2 over 81 to the 1/2 power and y to the 18 times 1/2 power. Remember that the 1/2 power is the same as taking the square root of something. So now I'm looking at my chart for the square root of 16 and the square root of 81. And wouldn't you know it, both of them come out even. Excuse me, and then I'm going to go ahead and take my exponents and multiply them. So 14 times 1/2 is going to give me 7. So that becomes my numerator. Again, I'm looking at my chart here. 81 to the 1/2 power is going to become 9. And then y to the 18 times 1/2 is y to the 9th power. I can't simplify my fraction any more than that. 4 doesn't go into 9. And I've got x to the 7th and y. Those aren't the same letter, so I can't combine those any further. I am done with that problem. Let's look at one last problem here and see if we can go ahead and simplify this one. So this time I have a 2, which is on the outside. It is not part of this exponent term. So inside the parentheses I have a 16, and it is to the 3/4 power. So I'm going to go ahead and I'm going to write this 2. But then I'm going to work with this fractional exponent here. So I've got the 4th root of 16. And again, I'm going to look at my chart, and if I see on my chart for quartic, if I know that term, then I'm going to go ahead and take that 4th root. So it is on my chart. I do know the 4th root of 16 is 2. And so now I have 2 times 2 to the 3rd. And that's going to be the same as 2 times 8. And that is going to be 16. So these things can be kind of scary. I expect you to refer back to your notes here as you pursue these fractional exponents. Most of the time here we're going to be looking at our fractional exponents, and we're going to be using our exponent rules that we already know. Don't forget about those. They don't change. Okay? And simplify all fractions as far as you can. And let me know what questions you have.